Hi good people, Titus here, and today we're going to be talking about behavior trees inside Unreal Engine. In this video we'll break down the key elements, which include composite nodes, decorators, and task nodes. Alright, let's not waste any time and just jump right into it. So we got a basic enemy character here. There's no AI yet. It's just a static mesh with some animations and a Niagara effect. The goal for this video is to get this little drone flying around this obstacle course, picking random patrol locations, and then to intermittently spin in a 360 circle. So very, very simple setup, but it should demo the effect of a behavior tree. Okay, so open up our content drawer, and the first thing we need to do is create a blackboard. So right click under Artificial Intelligence, select Blackboard, and we'll call it bb_enemy. The blackboard is basically like your brain. It stores a bunch of keys with individual values. So this could be booleans, vectors, objects, all sorts of things. In this demo, we're going to be doing a vector and a boolean. The next thing we need is the behavior tree. So just right click, Artificial Intelligence, and select behavior tree. And we'll call that bt_enemy. We'll go ahead and double click to open up the tree, and we'll dock it in the main window here. Now we can see that it comes standard with a singular root object, and then in the details panel we can select our blackboard. It looks like it automatically assigned it for me, but if it didn't, you can just hit the drop down and select it there. Now the first thing we're going to talk about is composites. So if I pull off this, you see I have three composites. I have a selector, sequence, and a parallel. Selector is going to be likely your primary first item that you pull off into a root. The selector will basically allow you to pull in a particular branch. And you can think of composites. Selectors are probably like trunks, and sequences are probably like branches. And then parallel is basically like a branch where you need multiple actions to happen simultaneously. So the first thing we're going to do is we're going to do a selector, and I'm going to call this my trunk. And we're going to create a singular branch starting off just to demonstrate what this behavior tree can do. So I will pull into a sequence, and I'm going to title this my patrol branch. Now it is important to note, I will add a test node here. Your order of execution is indicated in the top right corner of each node. So you can see this one is 0, then it goes 1, and then 2. The order of execution is top down and then left to right. So if you notice, if I grab a particular node and move it to the left, the number changed from 2 to 1. So if you're arranging these, be careful, because they will, depending on your orientation, will affect the order of operations that they happen in. So that is very important with this system. All right, but I'm going to delete that test node. Okay, so for my first branch, I want to pick a random location, which is going to be a location, so a vector. Then I want to move to that location, and then I want to wait. So the first node that we'll need is basically find vector, which you can see there's some current tasks in here. Nothing here is going to find me a location, so we're going to have to make a custom task. But we do have our move to and our wait tasks are already set up. So those are already built in, which is kind of nice. If we need to make a custom task, we can go to the top and select new task. And then we can give it a name. I'm going to call mine BTT for behavior tree task, and then underscore find target position, or POS. Now when you create that, it'll load you into the blueprint, but let's go back to the behavior tree real quick, and I'm actually going to pull off and select it into the task tree here. So I'm going to find a random position. I'm then going to move to that location, and then I'm going to wait. Oops, wrong one. Select wait here. Okay. Now the move to, I need a location marker, and this is where the blackboard comes in handy. Now, if you need to open your blackboard, you can simply double click it in your content tray, or if you already have it assigned, in the top right corner, you'll notice behavior tree and blackboard, and you can switch between them. I'm going to select blackboard, and then I'm going to do a new key. I'm doing a location, so that's a vector, and then I have to give this a name. I'll call it location patrol or lock patrol. and then I can go back to my behavior tree, and then under move to, the Blackboard is currently setting a key. I'm going to change that to be the patrol location. And then for the wait, I'm going to add a random deviation of 1 second, so it'll randomly wait between 4 and 6 seconds. And now we just need to find that target position, and then we're going to populate whatever vector that finds into the Blackboard key. And I'll show you how to do that here. So we'll go back to our behavior tree task, and pretty much the majority of your BTTs are always going to have a receive execute AI. So you can just hit this little override option and then choose receive execute AI. And then I recommend you always cast to your pawn to make sure it's valid and in the world and exists. So cast to BP enemy. This is important because if you're doing a project where you're deleting or destroying pawns, you don't want the logic to execute, or if your pawn's been destroyed. So, and you can have a behavior tree be used by multiple pawns. Like they can still kind of pull values. So depending on the logic you're going for, this is always a good thing to do. If the cast fails, I need to indicate that to the behavior tree. So we can do that through a finish execute node, and I'm just going to leave it false to let it know that it was a failure. Regardless if it succeeds or fails, that doesn't necessarily matter so much. The important thing is that we notify the behavior tree, because it is event driven. So if the behavior tree gets into logic where it executes this task, and this task never notifies the behavior tree that it succeeded or failed, then this behavior tree will never leave this task. It'll stay here forever. So you need to notify or give some way to notify the task that has been complete. But from here, we can pull off the controlled pawn, which is my enemy, and then I can get the actor location. From that, I can get a random reachable point in some radius. The radius value, I can simply right click, promote it to a value, call this the patrol radius, compile, and then for the patrol radius value, I'm going to do like 5,000 units. Starting off, I don't need any nav data. I just need to pass this into the Blackboard key. So the way I can do that is pull off the success pin for the cast, and we'll do a set Blackboard value. And this is the heart of how you modify keys, Blackboard keys anyways, from tree tasks. So you have the options to update booleans, enumerators, floats, ints, objects, rotators, vectors. In this example, we're doing a vector. And I'll give you my yellow pin, and then I can just pass this in here. And then remember, we always need to notify the tree whether it's done or not. So finish, execute. And then this one has a handy dandy boolean that I can just pass in through here. And now we need to do some key value. You just right click the key value, promote it to a variable, give it whatever name you want, because it doesn't necessarily matter. The important thing here is that you make it instance editable. So this little checkbox, or you can click this little eyeball right here. The reason that is important is because now that I've done that, I can come into my behavior tree, and now when I select that custom task, you'll notice I have that location key show up. This is how we assign which Blackboard key to be written to. So I'm going to tell it to write to the patrol location. And this is how I'm able to pass in this vector into the Blackboard key. So now that we have that, it's still not going to work. So if we, even though we've done everything correctly here, right? We've set the execution order, we got the behavior tree, there's one glaring issue. So if I play this, it's not going to move, right? And that's because we've never started this behavior tree. So to be able to start the behavior tree, we need to basically execute it for the first time. Now, the way we can do that is we can do it from the controller class. So currently, under my little AI here, if I select the root component and search for pawn, I think, there is a controller class settings, and currently it's an AI controller. I'll go ahead and just make a custom controller. So we'll do a new blueprint class, select all classes. I can just search controller, and then I'm going to choose AI controller, and I'll just call this BP underscore enemy controller. And now if I go to the event graph for this, I can delete these nodes. And under the functions override, I can look for on possess. I can say when this thing possesses, run this execution node, which we will do the run behavior tree. And then we'll do possess pawn. Actually, no, you don't even need to, because that is the basic class. We just need to select the behavior tree here. So this is pretty much the majority of the code for the controller class, but we need to use this controller in our enemy. So under your pawn or whatever enemy you're using, set the controller class to be that BP underscore enemy controller. So let's go ahead and play, and now we should be working here. So we got to understand the relationship between pawns and controllers in Unreal Engine. It's an important relationship to understand, especially if you're going to be doing any sort of custom AI. The pawn is the physical manifestation, of either a player or a computer AI. The controller would be like the soul. So your controllers can be human controllers or they can be AI controllers, and that's where the majority of there's a tightly knit relationship between the behavior tree, the blackboard, and the AI controller. So that's where most of your code is likely going to be residing, just because how Unreal Engine is basically set up for that. But all right, so we got the drone kind of flying around. Now let's see if we can get the drone to randomly spin around. Just as a example here, let's go to our behavior tree, and we're going to modify this a bit. So we got our patrol. Let's move this over, and let's move into another sequence, and we'll call this our we'll call it our action branch. Names don't really matter, you can call it whatever. And we want to do two things. I want to play an animation, and then I want to spin. There's nothing that actually spins, so I'll have to make another custom task. So we'll do new task. I'll do the task blueprint, and then I'll call this BTT underscore spin. And then I'll go back to my behavior tree, and I'm just going to call BTT spin. All right, so for the animation to play, I think, is number 6 for this demo. Oops. Oh, hang on. Freezing up. Number 6, there we go. And then for the spin functionality, let's go ahead and go to our enemy. And under the event graph, we will create a custom event that we will call spin. I will call it start spin, because we're gonna need a way to start and stop this thing. And what we can do is we can just grab our capsule component, and we will just add a local rotation, and then we can split the rotation. And I'm just going to spin along the z-axis or the yaw by 1 degree. And I can put this here, and that'll work pretty good for that. Now for the actual custom behavior tree task, we of course need to do our standard receive execute AI. And then just like we did before, cast to your enemy pawn, whatever you're using. Pass in the controlled pawn as the object. If it fails, remember to call the finish execute. I'm going to leave that as a failure. And then if it's successful, I can pull off as the enemy and call that custom event, which was start spin. And then of course I need to finish execute, and then I'll mark that successful. All right, so we got the code set up. There's going to be an issue with it though. So if we go and we play, we can see the animation started because you can see the propellers are stuck there, like those are rotating. But the action isn't actually, well, there's a few things going on here. So let me see if I can, let's go to the behavior tree. We can see it's never executing the second one. And that's mainly because there's no success conditions. That was primarily why that's happening. But there'd be another issue is it would do one, then the other. So we kind of need these to happen at the same time. So there's a different node for that. So let's actually drag these down a bit. And we'll hold Alt and we'll break these connections. And then what we want to do is a parallel action. And this is your primary executable. And then while this is executing, also do this. There's still going to be an issue with this, but this should get us a little bit closer to what we're trying to do, which is spin. But the issue, as you can probably see, is the nature of selectors, the trunk. So the trunk is our problem here. Selectors, the way they work is they find the first option that succeeds. And as long as that action succeeds, they'll never leave it. So we need a way to break out of this condition to go back into a patrol. And that's what we can use conditionals for, which they're called decorators in the behavior tree system. So what we'll do is let's go ahead and stop that. So for the action branch, we can right click on it. We'll add a decorator and we'll do Blackboard. Now we have to set up a condition that we want to basically select for. So let's go into our Blackboard. We'll add a new key called a Boolean. And then we'll say can spin. And we'll go back to the behavior tree. And then we'll select that little Blackboard condition. And then for the Blackboard key, we'll set can spin as the activator. Now, the other thing you'll want to do is the observer aborts. This is basically how quickly do you want the decision tree to react to a change in events. If you set it to none, it's going to finish whatever logic it's on and then cycle back around and then check when it comes to that point. When the event triggers, if you want it to reevaluate the entire tree, you set it to both. Or if you want it to do one or the other, you can do like self or lower priority. Typically, you're probably going to be doing both for the majority of this, depending on how important the decision is that's happening. So now that we have this, nothing has set that to true. So our little drone is just going to navigate around the map like normal and not spin around. And we can see that over here. So we basically need to set up some method to actually change this key to true, so it'll actually spin. So let's do that now. So we can go back into the enemy code and we set up this custom event. Just for simplicity's sake, let's get rid of that. We'll right click, we'll do a new, actually let's do event begin play. We'll come into a delay of say 2 seconds. And then let's actually change that Blackboard value. So we can pull off this into a set value as bool, which it's not a Niagara system. Let's uncheck that. It's a Blackboard. So set value as bool. We need a valid target. Remember, Blackboard is tightly knit with controller, right? So we need to get controller. And then from the controller, we need to get AI controller. And then from the AI controller, we need to get the Blackboard. And then we can pass this in as the target. Now for the key name, We'll mark the Boolean value as true, but the key name that we pass in, we can just say make literal name. And then you just have to pass the exact name that you called it in the Blackboard. In my case, it was can_spin with a question mark and a capital S. It is case sensitive, so at least I believe it is. All right, but with this basic logic here, this should now spin after 2 seconds. So it's moving, the 2 seconds hit, and then it basically spins. Pretty cool, but we don't have a way to exit the spin functionality, right? So let's go ahead and create another custom event. We'll do one up here. Add custom event, we'll do stop spin. And it's basically just more of the same for this. Control D to duplicate. But instead of marking the Boolean as true, we'll just uncheck it to mark it as false. Now we just need a way to call this stop spin. So let's go back into our behavior tree and let's see what we have set up. So we got a simple parallel. I think once we're done executing this, we can pull into a wait, and then we'll wait for maybe 2 seconds. And then we can create a custom task. So we'll do btt underscore stop spin. And then I'll pull into that stop spin custom event. And then we just need to basically code that, that logic here. So we'll go back over here and much the same, we'll go to our functions, receive execute AI. We'll pull into a cast2 BP enemy, pass the control pond in here on the fail, mark finish execute to false. And then on the true, we'll call the stop spin custom event that we made. And then we will call the finish execute, but we will mark it as a success. So now we have a success and a failure option for this task. All right, so let's see what this actually looks like. There's gonna be a problem with this one too. We're still gonna get stuck in our circular logic, but after 2 seconds, you can see our AI spins. And then after that, it should go back into patrol mode. But you'll notice there is no logic for it to ever exit patrol mode. Like it'll never do the spin ever again. So we go back over here. We're basically stuck over in this side. So we need to set up some way for it to kick back over here. So let's do that. So what we can do is we'll go back into our behavior tree. We need some type of node over here. Let's create a custom task again. We'll call this btt underscore. We'll call it random spin. I'm getting bad with the names here. So pull this into our random spin, and then we need to figure out the logic that we want to use for this. So much the same as we have been, we will receive execute AI. We will cast to our enemy pawn, pass in our controlled pawn as the object on the failed pin, finish execute, mark failure, and then on the success pin, set Blackboard value. This time, instead of vector, we're doing a Boolean. Remember the key, we have to right click, promote it to a variable, and this one is our spin key. And remember, it needs to be, instance editable or public. Otherwise the Blackboard won't see it, which means you can't write to the value. And then for the value, I'm going to pull into a random Boolean. This will randomly assign true or false, depending on what it's called. So, and then of course we need to finish execute, and then we'll mark this one our success. So now we have a success and failure condition. So we're looking pretty good here. Last thing we need to do is we created the key, but we never set up the reference. Go back to the behavior tree If you select your custom task, you have your spin key. Just assign it to the Boolean key that you set up in your Blackboard. And then with this, should pretty much be the majority of our logic. I'm going to press the apostrophe key so we can see some of the logic going on. And then if you notice, the can spin right now is set to false. It has a location patrol, so the variables are actually populating correctly. You can see this will randomly, so it stayed false on that one, but it should every once in a while turn true, and the thing should spin, and it should be able to exit that logic spin. So here's the spin one, and it should be able to gracefully exit that and continue on the patrol. And this is obviously a very silly demonstration. Like, I don't know why you would just have the thing spin randomly. You can have it chase the player, or, do whatever logic you want to set up, but it's kind of more just demonstrating the fact that you can do it. So. But yeah. All right, everyone, I think we'll cut the vid here to keep it short, but hopefully you have a solid grasp on composite nodes, decorators, and task nodes, and how they shape AI decision making. I also have a complete start to finish AI setup video if you need the full breakdown, so be sure to check that out. But as always, thanks for watching, consider subscribing, and we'll see you on the next one.